Hi there. So we are on chapter 2 in abnormal psychology. I'll briefly cover a section that discusses the scientific research, some of the components, at least. Again, not everything that's in the textbook, just a few things. So why is this such an important chapter, which it in fact is? Well, it turns out that for decades now, psychology has made an effort, psychology as a field, to establish itself as science. Okay, that is very important because if we are to be trusted in our understanding, explanations, and prediction with respect to human behavior, people need to know that we are making an effort to formulate our findings in the most trustworthy way, and that turns out to be science. Science is far from perfect. We don't have time in this class to get into the details of that, but science is also the best we have in terms of establishing trustworthy facts. The textbook gets into a lot of different important topics. I'm going to focus here on correlation and empirical research. So a lot of studies in psychology are correlational. Sometimes it's referred to as the correlational method. What is a correlation? Correlation is a mathematical term that basically says there is a relationship between two things, or sometimes they're referred to as variables. Okay? Correlation can be positive, negative, or zero. An example of a positive correlation is the relationship between height and shoe size. The taller a person is, the bigger their shoe size. The shorter a person is, the smaller their shoe size. So there's a sense that both of the variables go in the same direction, right? They either both go up or both go down. That's what positive correlation is. Negative correlation, on the other hand, is an inverse relationship in which when one variable goes up, the other one goes down, and vice versa. So an example would be perhaps there is a correlation between the amount of exercise and the number of visits to the doctor, to the family practitioner. And it could go like this: the more a person exercises, the less or the fewer visits they make to their general practitioner. Okay, and vice versa. So you see how those two variables in relation to each other go in opposite direction. And finally, there is no correlation, meaning there is no relationship. An example of no correlation would be the relationship between intelligence and height, right? Tall people are just as likely to be smart as short people. There's no relationship. We typically say there's no correlation, or the correlation is zero. One important thing to keep in mind is that correlation does not necessarily, and very often, does not mean that there is a causal relationship. Sometimes it means that. Sometimes we can establish that by doing a lot of different studies, finding the same relationships, and understanding better the mechanisms. But by definition, correlation is not causation. And for that, if we want to establish causation, we need to conduct an experiment. It's the experimental method. Again, I'm going to use an example, okay? I'm going to use an example of a research study that is conducted in the form of an experiment. Let's say I am studying the effect of psychotherapy on symptoms of anxiety. Okay, so I recruit a bunch of different participants who suffer from an anxiety disorder, perhaps generalized anxiety disorder, something we'll cover later in the semester, and the degree to which they can be helped by a certain kind of psychotherapy. Okay, the participants are recruited for the study. I split them into two groups. One group is assigned to the experimental condition, which is the condition where they receive psychotherapy, let's say for 6 or 8 weeks. And the second group is called the control group because they will not receive the psychotherapy. They may be on a wait list or they may receive some self-help tips, but it's not psychotherapy. And we call that control group because the control group does not receive the treatment. Okay, and then I measure the symptoms of anxiety. I start at the beginning of the study before I do anything just to see what the levels of depression are in the two groups. And at the end of the study, I go back and in each of the two groups, the experimental group and the control group, I measure the anxiety symptoms again to see if there has been improvement. And if so, if one group, preferably or predictably, I would imagine it might be the one in which people receive psychotherapy, experienced more improvement than the control group, which in this case might be just a waitlist group. Okay, that's an experiment by definition. Okay, what we call an independent variable is that which the experimenter manipulates. What does that mean? That's what the changes are in terms of the treatment. One group receives psychotherapy, one group receives waitlist, meaning they don't receive any treatment. That is what we call the independent variable, psychotherapy versus waitlist. Dependent variable is what the experimenter measures, okay? So in the case of this study, what I am measuring, as I mentioned before, are symptoms of anxiety. Okay, and that becomes the dependent variable. And it is really through these rigorous experiments in which the experimenter assigns groups into experimental and control groups, has independent variables that they manipulate and look at the effects those manipulations have on the dependent variable that become the foundation of an experiment. And in an ideal world, once we have findings from one experiment, we conduct the same experiment with different participants several times to see if our findings hold. Okay, that covers it. There's a lot more going on in that chapter. Make sure you review everything, but I wanted to give you a little bit more detail on these topics and use an example with the hope that that will actually help you learn some of these topics. Okay, I'll see you next time. Thank you for your attention. Bye.